For problems like this, I think it's always easier to look at the goal. So you have 3 reactions here that are known. So for this reaction, I know the delta H in this case is endothermic. This one's also, this one's exothermic. And we want to know what the delta H of this goal or final reaction is going to be. So we have 3 knowns, 1 unknown. And what we want to do is kind of match it up, either flip it, change the coefficients, and eventually have them cancel out to give us this final one, and then we can manipulate the delta H's as well. What I usually like to do is just kind of look for certain things. Things like oxygen or fluorine, I'm going to try to not worry about it till the end. But when you see something as complicated as CIF3 or Cl2O and then OF2, you kind of just want to focus on one at a time. So for me, let's focus on the first one, CIF3. So is there anywhere here that has CIF3? So there's one right here. Let's see if there's anything else. That's CIF3. The rest are not. So that's going to be it. Notice that this is on the left side and this one's on the right side. So I need to flip it. I'm going to flip it. So that means instead of this being on the right side, now it's going to be the left. CIF. Ooh, it's kind of laggy. CIF3. Arrow. CIF plus F2. I'm not going to worry about the delta H till the end because I'm just going to flip it. I'm going to look at it. So here I have O2, but like I said, it's kind of common. You have 2 equations with F2, so I'm going to kind of ignore it for now. I have Cl2, so let's look for Cl2. So here is Cl2. It is on the correct side, so I'm actually pretty happy with it. Let's see if everything else is okay. It looks pretty good, so I just kind of ignore it for now. Let's look at OF2. So here I have 2. Let me make sure I wrote it correctly, and I need 3. Is there anywhere else that has OF2? Oh, here's OF2 as well. So it actually works out. So let's see if we even need to do anything. Let's see. So if it's like this, we have 1 Cl, 3 OF, and then, oh, I have 1 CFF. So this will cancel out. Oh, here, let's see. I need 2 of these, so I need to flip and multiply by 2. So 2, 2, 2. And let's see if that works. So if that's 2, this cancels out with that one, so that's good. 2CF cancels with that one. Actually, I think that's it. I don't think you have to do anything. Well, let's find out. All right, let's add up everything on the left. Let's cross out anything that's similar. So CIF, there's 2 of these, so this crosses out with this one. Let's see, I have 2 F2s, so this will cross out with this one. So that's taken care of. Let's see, CIF. Oh, that's already crossed out. Oh, wait, no, I already did this one, sorry. O2, that's right. So let's add them up. I think that's it. All right, let's find out. So add everything on the left. I have 2 CIF3 plus F2. Oh no, yeah, I'm looking at the wrong. CIF3, sorry, plus 2O2. Then I have Cl2O plus 3OF2 plus, that's it. So let's see if it matches. 2CF, 2O2, Cl2, 3O. So it's all good. So all I did was just flip this one and multiply by 2. So this becomes positive 135.0 times 2. And you're just going to add the rest of them together. So 167.5 plus 43.5. Whoops, minus 43.5 plus 135 times 2. So I get a delta H of 394. So that's it. So just focus on one. Hopefully things start canceling out. In this case, everything kind of worked out for us. So see, these cancel out. CIF, there's 2 of them, 3. And then so we have that one, 2 O2s. So that kind of worked out. Add everything on the right, Cl2, 3OF4, and then everything canceled. So I think we're good. That's it. I forgot to do the extension, which is B. It says further, if you had 0.40 moles of CiF3 and O2 react as above, then how many kilojoules do we get? Okay, and we can do that. So here we have the equation. This is what we're going to use as a reference. So we have 0.40 moles of that. So that's our starting point, 0.40 moles. And we want to convert it into joules. So here the ratio is 2, right? So every 2 moles is going to give me 394 kilojoules. So every 2 moles of CiF3, and that's because of this ratio. So I have 2 to this number, and that's it. You just multiply across. So 0.4 times 394 divided by 2 will give me 78.8 kilojoules. And since it's going to be positive, it is going to be endothermic, which is what it means. It needs to absorb in order for this to happen. All right, that's it for this problem.